All right, last problem of this series. So our last combustion problem, which is going to be a little bit different from our others. So take a moment, pause, read through this, think about what you want to consider, think about your plan, and then come back when you need some help. All right, so for this one, they're talking about it being burning, which means that it's a combustion reaction. We want to make sure we remember that combustion is when we react a hydrocarbon with oxygen to form carbon dioxide and water. Now, however much the water is increasing in heat, that's going to come directly from the reaction. And here, because it's a constant pressure calorimeter, we know that the heat of the reaction is equal in magnitude to the Q. I say equal in magnitude because if we're measuring the Q as the water, the change in Q of the water, it's going to be opposite in sign. But that's okay. We can do that. So if we know how much the water changes, we can use Q equals mc delta T to find the heat of the reaction. Using this heat of the reaction, we can fill in every other DH of formation that we have. So, and leaving just the one that we don't know, using our heat of reaction, and all of those to solve for our answer. So our plan will be to use Q equals mc delta T to find the heat of reaction, and then using the products minus reactants and the heat of reaction to solve for the formation of the unknown. So this is a good pause point, again, if you haven't made it past this, to start working on the problem. Come back and see how you did. All right. So let's start with our Q equals mc delta T. We know we have 35 kilograms of water. I went ahead and converted that to grams, but again, you might want to go ahead and leave the conversion factor in so you can see that those two cancel, or you can do it this way. I filled in my C of my water right here, and it actually told me the delta T, so I didn't have to calculate that. I just filled it directly in, which gives me my 183.2 kilojoules. Now remember that this is for how much overall was burned, which is 4 grams. If we're going to fill this into DH of reaction, we need to first get it into 1 mole, because the DH of reaction is going to be for however many moles the balanced reaction has in it. So we'll take our 183.2, we'll divide by our 4 grams. That's going to get us kilojoules per gram right here. But we don't want kilojoules per gram, we want kilojoules per mole. So we need to get rid of grams, which is currently on the bottom, which means we're going to put grams on top, moles on the bottom. We put our molar mass in, and we get our answer. So this is kilojoules per 1 mole. This is our DH, right? Now, keep in mind that this is talking about the water, right? Because this is all done for the water, and the water is absorbing heat, so this is going to be positive. But when we go to fill into DH of reaction, we're going to have to make that negative. So now we can write out our reaction and we can balance it. We've got 4 carbons over here. We have 8 hydrogens, so we need to put a 4 here to balance that. That gives us a total of 12 oxygens, which now we need a 6 here to balance that. We can fill in our delta H's. So this is our gaseous water. Make sure to grab the gas one. This is our carbon dioxide. This is our oxygen, which we don't have to look up because it's a diatomic gas in its standard state. And then this is the 1 times this, which we don't know, because there's a lot of different compounds that could be C4H8. So because of that, we just need to fill in X. A lot of people may have started here and then got stuck and said, but what do I do with the DH? Well, the DH is coming from what we know got transferred to our water. Now, this is the step where when you go to fill in, make sure that you're making it negative, because this Q is for the water, but the DH is for the reaction. So it'll be equal in magnitude, but opposite in sign. From here, you can solve for X. Probably the way I would do it would be to solve for this whole thing first. Know that it's minus X. This is going to go to 0, but this is this whole thing. So 1 times X is just X. From here, we can solve for our answer.